When I got to the tutorial phase and I was no longer going through textbooks for the information that I needed, it's important at each of these phases to have a very sharp um, razor to apply to the material you're consuming. So when I would go through a tutorial, even now, I'll still search for tutorials, but it's for like a specific answer to something. So like it might be, all right, which API call do I need? That's like the super easy situation. Like, but the next more difficult situation is something entirely new. Like, okay, well, now I've got my machine learning model to go through on my CPU. How do I do this GPU stuff? How does the GPU stuff work? Like, get a few terrible explanations from the tutorials and then immediately use that to see, all right, there are some holes in this, and I've read enough of these or watched enough of these tutorials to see the thing that they're not covering because something still doesn't quite make sense. And so now go to the material that is even more direct, like the documentation, if it exists, or the source, and then be like, okay, none of this makes sense, but I can start to bridge the two and spend the mental effort and the literal sweat trying to connect them. And when I say that, I mean like it's the same muscle you use to understand the textbook material, but now you're applying it to, okay, the textbook material still exists. It's in here, it's buried in the source code. And the thing they're explaining in these tutorials poorly is also buried in the source code. So how do all of these three perspectives on this same one hazy entity correlate with each other, and how do I make them coherent?
In today's episode, we speak with Marcelle Bonterre. He's a senior machine learning engineer focused on natural language processing at Turnitin. Before Turnitin, he was either the first or an early engineer at several startups whose businesses range from smartwatches to FinTech. He holds a Bachelors in computer science from Wright State University. Marcelle spends part of his spare time mentoring new engineers through affiliations with various organizations and spinning through his rolodex of hobbies, including mountain biking, rock climbing, tinkering with electronics, roasting coffee, falling down Wikipedia language origin rabbit holes, or indulging his passion for autodidactic study of astronomy, quantum physics, and various mathematical esoteria. Marcelle is an immigrant from Trinidad and Tobago, and what I want you to take away from his journey is his focus on learning the skills needed to be successful in your data science career, even without a formal education in machine learning. Hope you enjoyed the interview. Remember to share this episode, subscribe, and like. It's a simple way to continue spreading the message of the benefits of tech-based careers. Listen to us on Spotify, Apple, and Google if you want just the audio experience. Let we go.
The show where we talk about data science in the Caribbean, highlighting practical ways that you can learn, get involved, and create your own impact using artificial intelligence and machine learning. This is the Caribbean Data Science Podcast with Mark Moyu and Jeff Sayon.
All right, Marcelle, welcome to the show. Really grateful to have you on today.
Thanks for having me, Mark.
Perfect. So tell us kind of where you live right now and what you're currently working on at the moment.
At the moment, I live in Pittsburgh, Pennsylvania, and I am on a pretty small natural language processing team working for Turnitin, which is a company in the education space. Their bread and butter is integrity products. So the one most people would know about is plagiarism checking, but we have since expanded away from strictly plagiarism checking to all sorts of variations on the idea of integrity. So plagiarism is a copy-paste integrity violation, but there are others, like you can have someone else write your paper. It's a totally original paper, but it's not your work. You can throw your paper into Google Translate. You can put your paper into, any other sort of online word spinners and all sorts of other things. So that's like one dimension of what we do. And then there are a few other different dimensions that we are looking to expand into. And the nature of the various use cases across integrity and like driving formative feedback for developing writers. So not only helping to curb disingenuous behavior in terms of academic writing settings, but also helping grow writing skills and creating tools to allow teachers to better administer those classes, either more efficiently or with greater clarity of purpose in what they're doing. So the nature of doing machine learning across all of those different use cases has sort of led us down a path of creating a bunch of reusable things across all of those use cases. So my time at Turnitin has involved a decent amount of tool making and a decent amount of trying to continually oscillate between being in the thicket of the weeds and zooming out to see the forest for the trees. So that means our features get reused across many of our different machine learning applications. The techniques that we're doing, the models that we're using are being repurposed continually throughout all of the different applications. And the kinds of models that we're developing are pretty fine-grained and get bundled together a lot.
Okay.
So it's a really interesting brand of how to do machine learning. And I think also another very important thing that has been top of mind a lot recently with my work has been sort of the manner in which we've been able to get explainability almost for free based on our history.
Okay.
And how we have sort of carried that forward as continuing to have it top of mind and also to bend our approaches even as we start using more of these big neural networks and like big transformer
language models and
yeah, exactly.
Okay.
Trying to maintain and not lose all of that explainability.
That's a pretty hard problem to solve. And I think the problem that you're working on at Trinidad has always fascinated me because imagine I'm a writer. Well, I'm a student. I have to write about topics that have been written before, and there's a fair amount of literature on it already. And then how do you now compare my writing style against another student's writing style, let's say locally within a class, and then, broadening that out to, okay, let's look at these essays from this school versus another school. So that's an interesting problem.
Yeah, and it's not only essays and long format writing. There's some of the other products through acquisitions and whatnot involve short pieces of text. So you might consider like responses to short answer questions, responses to short answer questions in the STEM topics. And then I don't know how you consider like nursing and law and all of that stuff, but the nature of the kinds of exams that are delivered for those topics have texts that vary quite differently from academic essay style writing and or like even like academic journal style paper style writing for like research papers. So
I guess for law you probably have to be very very particular in the way that you pose your arguments and things like that, right?
Yeah, it is. The various use cases are quite different, both like from the obvious level and then also how it affects the implementation of what you should do and whatnot. So I think that's also a very interesting, not challenge, but additional consideration that threads itself through everything.
Makes sense. So we do the show to encourage people from the Caribbean region to pursue data-driven careers. Share with us your view of how you think machine learning, AI, tech, right? You have all of those backgrounds and what those types of data-driven careers will play a role in the Caribbean's future, and even extend that to, I would say, our generation and the next generation down, such that what's the world going to look like that they have to interact in?
Oh, that's a really good question. I have a bit of a myopic view on that topic. And then also there's the like more strategic view. So bad news first, my myopia says that the barrier to entry for data science and machine learning is simultaneously low and high. I come from a non-traditional background. I don't have a PhD, and I don't have a statistics degree or anything like that. And so coming into machine learning, I arrived at just the right time where the interfaces that were present for me to interact with were high level enough that I could sort of opt into the additional complexity of figuring out what's going on under the hood,
Right.
as was necessary, and is actually quite necessary these days, because even though those interfaces are decently high level, they're really broken because people are churning out these features at a breakneck pace, even some of the big shops. So it's necessary to know what's going on under these interfaces. But even still, even though the interfaces now are forgiving enough that it allows someone to come in with minimal information and sort of pick up what they need as they go, I think I don't foresee everything being cleaned up and buttoned away quickly enough that you never have to think about it. So like in whatever language you use on your day-to-day basis, you don't ever think about how does this sort function work, especially in Python. You're like, it's just a sort or it's just a set. Who cares how it's implemented? You can't be that way with machine learning about any aspect of machine learning at the moment. And I don't foresee that changing for the next decade.
Interesting. Ooh. All right.
Maybe decade is too strong because things change fast, but maybe 5 years at least, 5 years. And so that means you can't necessarily obviate away all of the education necessary, however you acquire it. And I think in the Caribbean in particular, things are so chaotic, or stratified, I think is a better way to think about it, that the outcomes of people who have access to that kind of information sort of implies that we're not going to see as many of our potential brightest and best even have access to that information to start consuming some of that and contributing and participating.
Oh, that's heavy.
Yes.
Pretty heavy one.
I warned you.
Yeah. And I wanted to dig into something that you said around understanding what's happening under these interfaces. And I think one of the threads that people will pick up with you as a software engineer, you're speaking about interfaces and whatnot. So it's nice that you embody sort of the thing that you're very passionate about. But talk to us about the acquisition of that knowledge, right? How you kind of went about it. We'll dig into your career journey, but if you can give folks, a high level of what made you think you could go acquire that knowledge, essentially.
Yeah, a lot of wrong turns, for sure. So many wrong turns. I think for anything that's valuable, economically valuable, there's going to be a lot of people out there trying to sell what they think is a shovel to the gold miners.
Right.
And there's a lot of information out there that will massage your desire to learn the material without actually giving you any of the skills that would be useful to like have on a day-to-day basis. Like there's a difference between theory and practice, and in practice, theory is not enough. So after taking a lot of those wrong turns, and I mean, like, I'm not going to name names, but
sure,
a lot of top universities will have these programs as just as like cash generating things where it's like get a 1 year, like, or not even a 1 year, like a 1 semester machine learning certificate. And you go through the thing and you're like, I still can't do machine learning. What? I still don't know how to like do the thing. So after taking all those wrong turns, I think it is necessary to step back and realize how the field got to where it is today. And my opinion of how that happened is you have, just like computer science and software development actually, is you have some pure thing, and then you have some other pure thing. So if you think about electrical engineering and physics, or electrical engineering and math, or any of those things, and some opportunity presents itself or some problem presents itself that is in between the two, and some people have just the right blend of skills to pull just the right pieces from each of those two different previously extremely separate domains and bend it into something new and useful. When you realize that that is what has happened with all of the, especially computer science, but I think with computer science and machine learning, it's happened more rapidly. And so we've been able to see it. And so it doesn't feel as weird, but it is extremely weird. It just normally takes a lot longer. Anyway, when you realize that's what has happened, then it becomes quite apparent that what you need to do is get yourself enough of a mental model of what's going on in field X, what's going on in field Y, and in terms of like the not necessary knowledge of that field, the essence of those two fields, and then try to find the third, like in between, a necessary model for all of those, and then a separate effort of, okay, now let's try to connect all of these in a somewhat rapid version of what happened organically over the span of like a decade or in our case, I think 2 or 3 decades.
So you're essentially distilling down to, okay, there are these courses outside, there's field X, there's field Y, but there's this essence of knowledge that you need to essentially master and things that you need to be able to do in order to be proficient at your job.
Yeah. So if I were to speak less abstractly, someone at one point knew enough mathematics, specifically linear algebra, calculus, optimization theory, like convex optimization and all that other stuff. And someone also knew enough computer science to know, okay, GPUs exist. These are the various ways that we can write programming languages, and these are the various kinds of software level optimizations we can do, et cetera, and knew enough of those two things to then say, okay, if I want to solve this unique problem of how do we create a mechanism to do this kind of learning or mimic this kind of paradigm, how would I do that? How would I combine these pieces of information? And then they combined it. And if then you would like to replicate that, then you have to learn, okay, in isolation, I need to understand statistics. I need to understand linear algebra. I need to understand all of these things. And I also need to understand these other things in isolation. And like, you have to sort of work your way back through the exact path of the persons who invented the field. Mm-hmm. And I think that's the way that a degree program, especially like a PhD, will just sort of like automatically have baked into it. But when you try to go through these courses, they're trying to get you, they have their own agenda, I think. And this is my highly biased opinion. They have their own agenda, and it doesn't necessarily align with the mastery that generated the field in the first place.
Yes, that makes sense. And one of the things I want people listening to hopefully pick up is that level of mastery that you aim to achieve. That's one of the things that I kept with me when I first met you at one of those machine learning conferences, and it was actually a very applied machine learning conference. So I appreciate you calling that out. So in the first segment, we'd like to dive into your career journey. So tell us, let's start from way back. Tell us where you grew up. What were you like in high school in terms of your disciplines, interests, strengths, weaknesses, and the reason why I call those out is to provide a map for others that if they resonate with you, like, hey, Marcelle was able to do X, Y, and Z. And if they have one or two, if they fit 3 of the 4 things, they have some type of projection or some data to build a model, let's say, right?
Yeah. Well, obviously, I'm from the Caribbean diaspora. So when I was 11, my mom and I immigrated to Florida. And then very quickly, she linked up with a childhood friend. We moved to Reading, Pennsylvania, and then met some people, new people, and they helped us move to Ohio. And I spent the majority of my life until this point living in Ohio. In high school, actually, this has been inherent from day one, because I can remember, being extremely young and taking part in electronics and putting it back together, or like looking at systems in general and having this mindset of things are the sum of their pieces. And if something doesn't work, and this is a very rudimentary, obviously, because we're talking about childhood, if something doesn't work, then you can take apart the pieces and figure out the part. There's some method of understanding which part doesn't work, and maybe there's something you can do to remediate the malfunction.
Mm-hmm.
And when you put it back together, it should be resolved. And I think that innate or developed mindset of, and I think actually, if I go even further back, I would say that my mother was very, just like every other Caribbean mother, very stringent about education. And so one of the key lessons I've learned, and I think Sal Khan has this opinion too, but he obviously branded it as a growth mindset. But back when we were growing up, that term didn't exist. But essentially, at no point was I ever praised for being like, quote, brilliant or anything like that.
Right.
I was just always given by my mother some sort of arbitrary, it wasn't arbitrary. She had some sort of grand plan or whatever about it. I think she was just taking the material from the following grade and giving it to me a grade early. But anyway, she would give me this material and it would obviously be unintuitive and difficult because that's what new feels like. And the expectation is that at some point I'm going to get it. And we just have to keep probing at the material and keep trying and twisting and twisting and twisting our brain or my brain until it made sense. And so that discipline to stick with the discomfort of learning something truly new never left. And so you just get really uncomfortable being horribly uncomfortable, or really comfortable being horribly uncomfortable. So anyway, fast forward, I'm in high school, trying out all sorts of things. And I remember, since I moved a lot, as you remember in my story, in every move or every situation preceding the move, I remember being interested in something, but not quite having the opportunity to like pursue it. So then in the subsequent move, I would immediately, that would be like number one on the agenda. So on one of those moves, I pursued music because I remember being in the previous situation and thinking, oh, this person I know plays this instrument and that's so cool. So anyway, I move when we moved to Ohio, I walked into the band room and I said, hey, I don't know how to do any of the things, but I'm interested. Is there a role for me here? And so that was kind of like a crucial journey. And I think high school band in general is like a weird place, but finding that tribe of people and then also finding the other little niches of people who are interested in all the nerdy things that I was interested in high school allowed those things to foster in a completely like random search kind of random walk kind of way. So also in high school, which for me, when I skipped 2 grades and then repeated 1 grade because then I wasn't adjusting very well after the 2 grade skip. And so I repeated 1 grade. But anyway, in that time, I had found some computer nerds, and one of them in particular. So we were maybe 13 or 14, I think probably 14. And he'd already had like probably 10 years of experience.
What?
I know. I mean, his family were very well off, so he had access to a lot of things. And so, but like I think he didn't finish high school. He just got a job. And now that I've like gone back through his resume, it's very impressive. So by the time he was out of high school, he had already had like 20 years of experience somehow. At any rate, he made me aware of so many different things, Linux being one of them. And I remember desiring a computer, but obviously not being able to afford one as a child. And so then my girlfriend in high school at the time, her father had just like upgraded her computer. So I just got all her old computer's parts that didn't work. And so then I started scrapping together my computer, and obviously Linux is free. So you throw Linux on there, and obviously Linux in the early 2000s was not the most user-friendly. So that like the barrier to entry is just like, you have to learn a bunch of stuff if you want the outcome of having a computer that works and continually maintaining it. And so having all of these experiences of like meeting a group of people that foster your interests and like that working group kind of mindset, and then also having the idea of music, not only because of music, just it's good for your soul for lots of reasons, but music, just like sports, requires that determination and stick with itness that I think translates to everything. trying to train your brain to repeat muscular patterns, because the instrument that I played was the trombone. There are no buttons on a trombone. There's just arbitrary locations in space that sort of seem like the right place to be. And so how do you train your muscles to stop right when they need to so that you have the right pitches? It takes a long time. And when I left high school, tragically, I guess, but I mean, obviously it worked out fine for me. I didn't think I was smart enough for any sort of engineering, even though I was pretty curious about computers.
Oh, no way.
Yahweh. The US education is a whole other topic, but that's neither here nor there. But anyway, so I decided to study music because I was still very passionate about it. And at that point, I'd become quite good at it. So I went into a music program and started dating eventually a girl who was a pure math major with the intent of becoming a doctor. And I would like look over her shoulder when she was doing her work. And, you know, obviously as she was going through it, puzzling through it, I was there puzzling through it with her. And I'm like, this stuff makes low-key make sense. So after that relationship didn't last, I had developed enough confidence in my capabilities to learn anything. And given the, so especially in music school, the barrier for what is considered good and what is necessary to be, quote, good is just like sit in a practice room for 8 hours a day and just like drill this thing. It's extremely tedious and extremely purposeful. And I think that determined tedium purposeful combination translates super well to everything. So when I switched over and I decided to like downgrade, change my major and all this other stuff, it all worked really well and the material just clicked super easily. And my opinion is that because of my experiences in high school with all the various computer things I'd done, that I was primed to learn software pretty easily because I'd already sort of struggled to learn software because I was trying to write programs in high school, but unsuccessfully. And I'd done a couple bash scripts and whatnot and try C++. And it's like C++ with no guidance is a bad experience.
C++ in general is probably not the best experience.
Yeah. I think that's a fact statement too. So let's fast forward through the story a bit because it's a long story. But essentially, switched my major, cobbled together some sort of a resume based on the things that I had done in high school, and was able to talk myself into an internship at LexisNexis. Then chance encounter and apply for another internship at a tech accelerator and parlayed that into my first job at a startup as the first employee. Nice. And through all of this time, I didn't really have nights and weekends, but not because of any sort of like draconian, I'm trying to like make it. I think if you have that is like, it's kerosene in the sense that it will help you burn hotter, but not for as long. And what you want is hot coals that you can cook breakfast on. Like it'll stay warm or reasonably hot for an extremely long time.
Yes.
And so for me, the hot coals was just my ability to determine what I was excited about and continually chase that. So if that meant that I was looking at Node.js and trying to make a web app in Node.js, if I lost interest in that, I would just move on to the next thing that I was interested in. Because I think keeping that spark alive is more important in the long run, or at least to get through the phase of you're just trying to cover a lot of ground education-wise.
I had a question. So what I find interesting about your story is you didn't have access to computers growing up, right? And I kind of wanted to show a flip side of the coin. I had access to like every computer almost that existed. My dad had a computer company growing up, and I couldn't give two shits about it for whatever reason. And it fascinates me to a very high degree, such that only now as an adult I appreciate computing. Whereas like that's what I grew up in, right? Building system, networks, all those types of things were in my, like I could build any server that I wanted to in my house. which is kind of crazy.
Yeah.
And you didn't have any of that, yet you had this insatiable desire to sort of go after computing. So I find that quite interesting.
I forgot a crucial moment. My mom was friends with some people who owned a what is that? An internet cafe.
Ooh.
Yeah. And so I would go there and play computer games and quickly lost interest in the computer games and became more interested in the computer. But obviously, those machines are there for business. You can't take them apart. You can't install stuff on them. You can't, they're not yours. You can't really learn anything on them. But
Makes sense.
I think the one thing it did was got me excited about the idea of a computer, because before that point, I'd never really, like, I remember when my mom sat there and taught me how to use a web browser. So that was when I learned computers existed, one, and two, you can do things with them. The things you can do with them are amazing because Quake 3 existed.
Yeah. I wish I had your sort of foresight. I was just like games, and then I realized, hey, I have this extremely addictive personality, so I should probably not play video games. So I shut that down real quick. And as you see behind me, I have a keyboard, which I have.
I do too.
Oh, solid. That's perfectly a prop. And if you put us both in a room and we had to survive, you would survive. I won't. And what's interesting, I bought that recently, a couple of years ago, out of the recognition that, and this is something I'll probably dive into a little later on, is the mental development of playing music or that process of learning. And as I started following more and more machine learning people, the ones who are really, I don't want to call it gifted, the ones who are very good at bringing out something new or having a very relatable intuition tended to be people that played music. And that got me very curious about, hey, there's a whole part of my brain that is just dead because it doesn't know how to think in that particular way. So any thoughts there for folks that are listening?
Yeah, I was alluding to that earlier. My intuition about the mechanism that results in that thing that you've observed is both that music forces you to adopt this certain work ethic in order to even get the most basic things. And every musician, no matter what level, their level of mastery, when they start a brand new piece they've never seen before, they start it the slowest, like tediously slow, comically slow, even if they're incredible. And it's because it's just, that's how it goes. That's the process. There is the process. And so that obviously, that metaphor translates very easily and very naturally. The other side effect, though, of doing something like that, of ingraining something inside of your bones, is that you don't have to think about it once you've done that part, and you can now make higher level connections.
Right.
And so I think if you can get to that point with any material, whether it is the mechanical adaptation of moving your body to create music, or understanding back propagation well enough that you can then say, oh, well, if back propagation works this way, which I understand thoroughly, then I should also be able to do this thing. Or if neural networks work this way, then the reason mine isn't working is because, and make some sort of what seems like an illogical leap or a non-connected leap.
Okay, great. And one other quick thing that a friend of mine recently, he has a RAS, so he was kind of explaining to me some of the philosophies of Rastafarianism, and he was saying, hey, music is a technology, and that's something I'd never really paid attention to as a thought, like it's a technology. So what's your thoughts on that statement?
Oh man, I have so many thoughts. I totally agree. I had this one moment, and this has repeated throughout my life since I've been very intimately connected with music. But I remember being in undergrad and having had a really rough day and coming home sort of disoriented by how addled my brain was from that rough day, and like frantically searching through to find this one extremely specific piece of music to go play that piece of music, not myself, but just to like listen to it. And as soon as I found it and I hit play, it was like everything in my body just like unwound, and I was just able to like, oh, and it was, I think the only metaphor that I feel is appropriate is the consonant and dissonant vibrations of strings. If you think about it from like a physics perspective of like harmonic oscillations, there's destructive and constructive interference. And I think controlled interference, which is what you can describe music as, someone else is controlling the interference of how everything, how the sound waves around you are moving, can result in my very unscientific opinion, potentially constructive interference in your mind and allow you to think different or better thoughts.
Wow. That's a cool way of looking at it. We'll keep the music thread going. So can you continue with your career journey so far, as you hopped into your first startup internship that you snuck your way into as employee number one?
Yeah. So essentially, if I were to roll through that zone pretty quickly, I was frantically learning new material, but not out of trying to, continually upgrade my life, but I was just like frantically chasing the motivation and of whatever I was interested in. And a natural result of that is covering a lot of ground. And amplifying that is being in a startup where there's more things to do than people to do them. And so you just end up having access to a lot of things that can be done. So you can cover a lot of ground. And so I did that. Then once I was done with that startup, someone I had met through that startup was starting another company, and I became the first engineer at that company as well. That's Dave, and which they just IPO'd, by the way.
Oh, wow.
Yeah.
Ooh, hey.
It's pretty cool to see that like come full circle. I'm like, oh, wow, they really did the thing.
What problem were they solving? Or what were they building?
Yeah, I would say it's like a microfinance kind of situation where you can give people without traditional access to money, give them access to money. And the specific bent that they had was people who need money regularly don't necessarily need hundreds of dollars or thousands of dollars. They're just like always short on a couple of things. And so their problem actually, well, okay, so Dave is interesting because that was my first blush with machine learning.
Oh, okay. So you were a software engineer and then you got to experience some type of machine learning there.
Yeah, well, I in the pursuit of solving the problems that the Dave platform necessitated, I had the idea that the few bits and bobs I'd heard about machine learning might be a thread I wanted to pull on to see if it could help me solve my problem. So it was an entirely like practical endeavor to start going down the road of machine learning.
Yeah. You weren't like, hey, I want to go get this big salary. I'm going to look at machine learning, or I heard about this. It's just like, hey, that could probably solve the problem. I'm going after it.
Yes, exactly. And I think continually guiding my journey through software and my career by that North Star, which, was exemplified in my previous job before that, where I was just like learning whatever was necessary at the time because there was just always this very specific thing driving me. I think that I stand by that being the most sustainable way to go.
Okay.
Like you might be a superhuman that can just be like, I want a big paying job, so I'm just going to learn whatever's necessary. But I have not found that to be the most sustainable fuel for myself. So I moved to Dave as the first engineer. They were solving this microfinance problem where, if I were to give it like in plain talk, we predicted based on your historical spending when you were going to run out of money next.
Oh.
And try to give you like a forecast, like a weather forecast of when we think you're going to run out of money, so that you can way ahead of time borrow some money, a small amount of money, so that you can bridge that gap and not get an overdraft fee and all the various other negative consequences of running out of money, of which an overdraft fee is literally just the beginning.
Yes, they're expensive.
Yeah. And so that idea of, okay, if we have this historical knowledge of a person's financial history, how can we figure out what they're going to do next and when it's going to happen? You know, now with the wisdom of hindsight, I can see, and all of my machine learning knowledge, I can see that, yeah, that is the perfect problem for statistics and math to be applied.
And that historical problem exists everywhere.
Oh, yeah. I mean, that's like the generalized statement of what, you know, statistical inference is. It's given historical data, can you predict a new event that, you know, has the same features as the historical events?
Question. In that time, what would you rate yourself as an expert software engineer at that time? Or you were just really good at getting things done and understanding the problem? Tell us some thoughts there.
Yeah, I wouldn't say that I was my current aesthetics say that I wasn't what I would call good until 3 years ago.
Okay.
And I would say at that point, I was in very much the middle of my journey.
Okay.
And I'm not saying that I'm at the end of my journey now. I have very nuanced thoughts about all of that. But anyway, I was definitely still in a point where the landscape of what is just like base level necessary to be effective and do all the things that you need to do as a general software engineer, especially in the context of startups, is huge. If you were to know as little as I knew then and go to like some giant company, you'd be totally fine. You wouldn't even notice that you didn't know something.
Oh, I see. Okay.
You would
but
be
in a startup environment.
Yeah, in a startup environment, you're continually slapped in the face with all the things you don't know and the extreme consequences of getting it wrong. Right. Like I made a lot of mistakes, a lot of very public mistakes.
Ooh.
Yeah. Like I would make a notification system and it wouldn't work. And someone would be like an angry customer. And because it was a startup, I was like on the line with that customer, like, oh, let me fix your account. Let me go into the database and fix the thing.
It's a good experience though, right? Would you say?
Yeah. Trial by fire can be good if the fire doesn't like cook you to death. You know, you don't want to get 3rd-degree burns. You just want to be hot stoved a little bit.
I like that one.
So at Dave, I discovered that machine learning might be an approach to the problem that I want to solve. And I started like pulling on that thread a little bit. I started going through Andrew Ng's course and, you know, picking at the corners of it. And not everything makes sense because you don't realize that even though he goes through this course super gradually, generally the people that are able to like go through that and then do something after it with that knowledge have had a certain background in mathematics.
Yes.
So I was able to cobble together some sort of system that did something for the forecast. And then actually, this was also my first blush with natural language processing because bank transactions, if you've ever looked through your bank app, are garbage. The names of what you're like, I don't even know what this is. What is CHS? You know, who is this? So wrangling that text of what the transaction name is into something that you can show to a person in an app to say, hey, you're going to spend $10 at Starbucks in 3 days, and that's going to make you overdraft, was a problem that I didn't even know natural language processing existed. And I just like solved the most intuitive way that I could, which was to look at the patterns of bank transaction names. And I recognized that there was a pattern. There's like institution name, which has probably been a few letters dropped for truncating, you know, the total size. And then there's some information here, and the institution name usually shows up in a certain part of the string, and like noticing all the different patterns and then creating like the most impressive amount of regex I've ever written to like essentially in this particular sequence, look at this part of the string, regex through this part of the string, grab this bit, look at this part. If you don't find it here, look here, and then do these things and all sorts of different manipulations. And it was like horrendously complex, but also fit together beautifully. And even in retrospect, I still think it was the right move. And it required no network calls. So like, I didn't even have to go to like one other solution I came up with was, well, if we had the time, we could call the Google Maps API or, something to like render this name through a search engine to see if the search engine can find something more realistic for this and then rank the results and match it that way. But this required none of that. So no network calls. It was crazy fast. After that job, I moved to Ernie. Ernie essentially did price protection. So if you bought something and then later at some other location, the price dropped, or even at that location, the price dropped. I think it was only at that location. At that store, the price dropped. Ernie would automatically file a price protection claim for you, and you could pocket the difference between what you paid and what the price had dropped to. And that involved a lot of like browser automation and, typical software engineering type stuff. So that was the end of my machine learning journey for a while until after Ernie. So I met a woman in Los Angeles, which is where all these jobs were. And she, my current girlfriend, had just gotten into her master's program all the way in Pittsburgh, Pennsylvania. And so I was like, well, do I want to stop this relationship with this person I kind of like that is going pretty well, or do I just want to move across the country? So we packed up and moved across the country. And
so
along that way,
you got into machine learning because of a relationship? Is that what you're saying? I'm just kidding.
I'm not going to refute that. But we took like a month. This was a great journey, actually. We took a month and like rolled across the country and did a lot of rock climbing and mountain biking and all sorts of stuff. So we chilled. But across that time, the next thing I was looking for was, okay, I've done the finance thing. It doesn't feel as good as I wanted to. I've always been passionate about education because I've had to learn things like at no point in this journey that we've talked about thus far have I ever not been learning.
Yes.
And so anyway, I get the job at Turnitin because it fits all the bill of all the things that I was interested in. And they were looking for a machine learning engineer. And I would, especially in hindsight, not say that I was qualified to be a machine learning engineer. What I would say is that I was at that point a software engineer who was just pre-good. Like I was on the precipice of being good. And that was a very useful fit for the job at the time because they needed more engineering skills, which I had. I had a wide swath of skills in everything. So I could do a lot of things day one.
Yes.
So over the time that I've been here, I have done all the engineering things, and obviously being exposed to more machine learning, especially in a production environment and especially up close like that, you can't, especially being a very curious person, you can't help but be like, I want to know all this stuff. I want to know more. And after all of the false starts that I mentioned earlier, the eventual plan that I came to for how do I like know this stuff so that I can be useful in the same way that my colleagues are, which by the way, all of my colleagues have like minimum 15, the majority of them 20 years and some sort of PhD type situation. So it's a high bar to cross.
Yes.
And the answer that I eventually found to that, based on the mechanism that I described earlier of look at what the field required to be invented and try to retrace the steps of the people that built the field, essentially led me to going through a bunch of university machine learning, software engineering type program requirements and looking at the courses and the textbooks required for those courses, and then just cover to cover reading all of them.
Yeah, I remember you telling me that when I first met you. You're just like, yeah, I'm just reading textbooks and papers. And I'm like, whoa, why? And I think one of the things that stick out to me is the difference of approaches. In one where your education is feeding you, and to some degree that limits your field of view of kind of what's out there, right? Because someone's spoon feeding you that material and saying, this is the way, these are the things that you need to know, versus your approach where you looked at everything and said, you actually went looking for it. So I think your mind was actively primed to answer certain questions versus in a spoon feeding education type thing. And this is something one of my education grandpas told me, right? So when you get a PhD, your advisor's advisor becomes your grandpa or grandmother.
Mhm.
And what he was sort of telling me, when you go to read papers, read the abstract and pause, and then ask yourself a series of questions before you continue reading. And that way your mind is actively looking for ways to answer that question. And I had, as a PhD student, you're just struggling reading and you're trying to read every word, understand, and completely abysmally failing every time.
Yeah, that's how it goes for sure. I think one of the important things to point out, though, is that reading all the textbook materials that I just described reading was crucial and necessary, but still insufficient.
Mm-hmm.
And I've now become very opinionated about what is necessary to master anything, or what I think is necessary in my necessary mechanisms for my brain to master anything. After that, the application of all of that knowledge through a project or a series of projects will necessarily highlight, just like in the startups, where I could see very clearly, because of a problem that we literally had, like an active fire, where I was like, I don't have the information to know what to do about this. And so then you go searching and you're looking for a certain signature that the answer is going to have on it.
Mm-hmm.
Likewise, going through a project with all of that base and foundational information illuminates perfectly the knowledge that you need and the kind of knowledge that you need. You're like, I don't need to know how backpropagation works, like from a mathematical point of view. I need to understand how PyTorch is doing the things and what all of these things mean as I'm going, like it's a different kind of information. And so for that information, then you go through this this ocean of a mix of YouTube videos, tutorials, and documentation, and like literally reading the source code of Hugging Face transformers, Hugging Face, TensorFlow, PyTorch, and PyTorch Lightning, like reading through the source code of all of those things for the specific problem that I'm like, being not afraid of that API barrier.
Mm-hmm.
And then just going past that and saying, okay, how does everything work? And actually, that's a lesson that I got from my job at Ernie. I had an extremely good manager at that point, and I was failing miserably at some project that I had been assigned. And one of the things he asked me was, how does this thing work? And I was like, well, it kind of works like this, this, and this. And he was like, no, but how does it work? Like, what are the details of it? And he's like, have you ever read the documentation for how, like, the RFC or the protocol implementation or the protocol description or any of that stuff? And I was like, no. And it never occurred to me to just like go read the source. So whenever I have in my last 3 years encountered a situation where, I was just super confused about something, and in machine learning, that's just going to be like the default state forever because things are changing so rapidly. The only answer is to go read the source and try to puzzle through how this connects to everything, what the original implementer did, and like really make sense of it as if you had wrote it yourself.
That's a very powerful statement. And I think again, a much deeper appreciation for that at NVIDIA. So like prior to my entry in NVIDIA, okay, you thought the world was a single GPU, right? Okay, you get one GPU and you're doing machine learning or you're doing deep learning, but in reality, production systems run thousands of GPUs or hundreds. And and how do you now do distributed training across hundreds or thousands of GPUs? That's a software engineering problem. And I've become a lot more sort of like yourself, opinionated as to what a functioning data scientist will be able to do, right? And there's functioning data scientists in a big company like Facebook or Amazon or Google versus a functioning data scientist, let's say in a startup, where I personally think software skills will take you, so much further because of all of these API layers that have abstracted all the statistics and things like that. Not to say that you don't need to know them, as you're saying, you definitely do need to know them to figure out why algorithms are converging or getting good results.
Yeah.
So yeah.
And actually, you mentioned that NVIDIA has sort of catalyzed you to learn more about the GPU situation and some of like how that all works. And I actually, within the last month, have been going through the NVIDIA source code and documentation for how the GPUs work. And it's like, I have this intuitive understanding from my day-to-day work, but then understanding literally the layout of the GPU and the GPU architecture and like what determines when information gets passed into and out of the GPU and all of that stuff has just made everything so much easier.
Well, I'm going to throw a wrench in your whole process there, because a big paradigm that's happening now is you don't communicate with the CPU anymore. You load that data directly onto the GPU because you have in the GPUs, you have bigger caches. And this is where I'm getting to the edge of my current knowledge. I'll go with your particular paradigm, current knowledge, because I'm digging in more into architecture as well. And all your processes live on the GPU and they pass data back and forth to each other. You're no longer pushing data back and forth to the CPU, and things are blazingly fast. So that's a
You're referring to NVLink?
So there is a networking component of that's crossing GPUs, right? So I have one GPU with this super efficient interconnect to another GPU. So I can now pool their memory, but even within a GPU. So now when you go to do model deployment, and let's say you have an ensemble model, that model will now live on the GPU. And instead of the CPU passing data to the GPU, that data can come directly into the GPU, and all the different processes on the GPU prior to some of the new memory formats that they've done. You would have had to push that data back out to the CPU from process A to get it to process B. But now they can communicate directly on the GPU. So things are just a lot faster. And then you hold multiple models on a single GPU in production. So that's kind of cool. Something I didn't think about. You're like, oh, you have a GPU, you have a model, it's serving requests, and you didn't think about how can I actually fill this thing up and get the most bang for my buck, right? So little things like that, you won't learn in our course, which is sometimes kind of sad when you go through school.
Yeah. And I wish they would make like, I think if they spent the first month of a course just really giving you visceral understanding of how much it is necessary to understand the nitty-gritty details of everything, I think that would change everything, because it's like, I don't need to know everything right now, but I have to have this process in place for how I acquire new information and answer new questions. Like the majority of your questions and my questions on a day-to-day basis are unfortunately not answered on Stack Overflow.
It's sad. It's actually very nerve-wracking, because you're like, oh, this new bug came up, and you're like, oh, what's going to happen? What am I going to do?
Yep.
And you, like you're saying, you have to go dig into the source. And then another thing I wanted to comment on was, for people that are learning machine learning, most of the examples are very simple.
Oh my God, I know. And it does not translate to what it is I'm working on at all. I'm like, this doesn't help me at all. How many times can I train the housing model?
And I always advise people who are, let's say, going into a boot camp, or, you're trying to short circuit the path to getting a data science job, and you post a common project, just don't post it. At least for me, it does not signal to an employer that, hey, you can do something novel. You can do something outside of the box, versus saying, okay, I'm going to go scrape together this Twitter data set on my own, completely random. It's going to have, 500 data points because that was painful enough to collect. Great. But you built an entire project. It sucked. But I went through the entire mechanics of putting your servers together. All of those things. I
emphatically agree with everything you just said, because it's a whole different scale. It's like not even the same as following the tutorial.
And can you comment on this notion of tutorial learning versus self-discovery learning? I think this is something I ran into, right? I think if you, having gone through a PhD and your brain just getting abused to some degree, right? I became very disingenuated with the formal education process of sitting in a class and you tell me these things. And I'm like, this is not really what I need to know to solve the damn problem that's gonna help me keep my job or whatever, right?
Yeah, exactly. So when I got to the tutorial phase and I was no longer going through textbooks for the information that I needed, it's important at each of these phases to have a very sharp razor to apply to the material you're consuming. So when I would go through a tutorial, even now, I'll still search for tutorials, but it's for like a specific answer to something. So like it might be, all right, which API call do I need? That's like the super easy situation. Like, but the next more difficult situation is something entirely new. Like, okay, well, now I've got my machine learning model to go through on my CPU. How do I do this GPU stuff? How does the GPU stuff work? Like, get a few terrible explanations from the tutorials and then immediately use that to see, all right, there are some holes in this, and I've read enough of these or watched enough of these tutorials to see the thing that they're not covering, because something still doesn't quite make sense. And so now go to the material that is even more direct, like the documentation, if it exists, or the source, and then be like, okay, none of this makes sense, but I can start to bridge the two and spend the mental effort and the literal sweat trying to connect them. And when I say that, I mean like it's the same muscle you use to understand the textbook material, but now you're applying it to, okay, the textbook material still exists. It's in here, it's buried in the source code. And the thing they're explaining in these tutorials poorly is also buried in the source code. So how do all of these three perspectives on this same one hazy entity correlate with each other? And how do I make them coherent?
Oh, that's beautiful. That's what I live every day when I wake up. I'm like, okay, I'm gonna deploy this model and let me go dig into BERT. Oh, I just have this big, huge API wall. What's happening on this? What can I do? Great.
The Hugging Face Transformers documentation is simultaneously amazing and bad.
Yeah, it, and I think you and I share similar traits where you kind of want to dig in. You want to know why this bloody thing is working. And even in my own journey into the mechanics of BERT, you had to go look in so many different places for someone to clearly say and simply say, this is what's happening. Right.
Yeah, I think also developing and practicing and growing the ability to ask the right questions. So I say it that way because it's not a skill that you can just tell someone, this is the, like, ask this meta question in order to figure out the actual question you need to ask. It's not that simple. You just have to like learn from asking all the least efficient, least good questions. So one of the kinds of questions that I've learned to ask is like, for instance, why this batch size? How do I determine the batch size? Why this learning rate? Why this? Why that? You know, why everything? Which are the hyperparameters that matter? You know, instead of just arbitrarily going up to like grid.ai and like sweeping over every single thing that I have a toggle for. Like, why? What does each of these things do? And honestly, there's not an explanation for most of it out there. But if you can experiment enough, and this is how I approach my work, I experiment through all of these different things. And now, like, for instance, one problem in particular I've been facing recently is I've been training a language model on bibliographic references.
Okay.
And I had a few hypotheses about what language model I should start with, like which architecture, and the mechanism that would make the training, quote, work. Work being defined by have low training loss or validation loss. And as I was going through that, I discovered, okay, well, I keep running into all these NANDs, and I have two 8 gig GPUs. And when I use the giant model, it doesn't fit on the GPUs. When I use the super tiny model, it doesn't learn very well. When I use this like intermediate model, it at least works, but it doesn't converge on anything super useful. And so then you start toggling all these like other things like, okay, well, I toggled the batch size. And actually, despite all of the internet saying bigger batch size, max out the batch size, I found that I get really great results with these tiny batch sizes. Why? What could possibly be going on? And so then you have to think, okay, what is going through this model and what is it doing? Well, the model is getting a tensor. the tensor is of a certain size, and my data exists of a certain size too, of a certain number of like real tokens versus all the padding. And the model has these attention heads, and these attention heads will attend over these. And so if my tensor is super big, and because my model is super big, then the attention's really diffuse. So maybe if I make my actual real data very small, like come up with an
You can kind of
explanation.
focus in almost and
Yeah, like a hypothesis. And so then the hypothesis I came up with was, okay, well, if I have a small batch size because my data is very small and I truncate my data to a pretty short size, I was truncating at 12 tokens. Then, and I use a small to medium size model with a reasonable number of attention heads, then I might be able to saturate my model by allowing those attention heads to like super attend, like basically give them so little data to work with that they're just like hyper focusing.
Yes.
And
cool.
Then it'll just be like, yeah, this is an easy problem for me to solve as a model. And I observed that the loss went in a positive, a favorable direction. And so like it's that kind of, if I do this, what happens? Why? What is possibly happening under the hood? Because of the information I have from having read the textbooks, I can say, okay, this is what the model is doing. So that's how it all fits together. But it's like being able to ask those kinds of questions is a grown, learned skill that fortunately for me, I'm on the other side of, but I don't have great wisdom for telling someone this is how you can develop this.
Interesting. So I wanted to ask a question around, your experience as a machine learning engineer. What would you say to folks thinking about that as a career, especially software engineers who would make the left turn or the right turn or run into the wall of machine learning engineering?
I sort of feel like if you're already a software engineer, you can do it.
Cool. Only
problem is that most people have, especially the way capitalism works, it rewards you for doing the thing you're good at. And so the only problem with that model is that you forget what it's like to be bad at something, like catastrophically bad at something. So, and I mean, I get that there's like a, when do you cut your losses and admit that you don't want to pay the price that is necessary to enter? So that is a question you should reasonably ask yourself. But I think it's only a question you should reasonably ask if you have set up the schedule properly. Yeah. A lot of people were like, okay, I'll give myself 14 weeks to go through this course. And if I'm not a machine learning engineer after that, then I guess I'm not smart enough. It's like, no, I've been at this job for 3+ years and I still feel like I'm continually big brain time trying to like, what's the next level look like? And every time I learn a new way of thinking, a new way of shifting my brain, a new like magnification level, it helps refine, like sort of through a back propagation process, but it helps refine the way I look at everything that I've previously experienced. And it helps me figure out how I can move forward again.
Great.
So, yeah.
So I wanted to shift as we've covered your career journey. And I think the things that stick out are you've leveraged your background in learning in music, but the rigor of learning music, and have applied that simultaneously to the rigor of just learning new things in your machine learning career. But you're a sports enthusiast. So I recently started back climbing and riding myself. So tell us about, how that has, I don't want to call it giving you balance, but how has that added to your equation of, you're a whole human being doing all this machine learning stuff. Tell us about that.
I unfortunately approach everything very similarly.
Yeah.
So with mountain biking in particular, so actually both with coffee roasting and with mountain biking, there is definitely the same approach where, I cover the landscape grossly and at a very high level. I don't intend to make any sort of like amazing retention from the material that I cover. And continually practicing and asking myself questions that are purposed to help me improve. And it's not like generic questions like, how do I get better at this? But it's like, I just had a good time doing this thing. Like the roast that I just made was amazing. Why was it so good? What did I do? Or I was just mountain biking this trail and damn it, that was the best I've ever run through that. That was the fastest I've ever run through that. Why was I able to do it so well that time? Or conversely, when the thing goes horribly, which is actually more instructive, why does it feel so hard today? I was amazing yesterday, or I was amazing 3 days ago. And as I'm going through the activity, so that's both retrospective and pre-perspective. I don't know what the word for that is, but ahead of time, there's the post-mortem and the pre-mortem, I guess, whatever. There's also in the moment questioning. So the zen that I experience while I'm mountain biking, especially downhill, which is quite fast and very like reactionary, I'm asking myself quite a lot of questions immediately after a thing happens. So like I'll like carve through something amazingly and be like, oh, I have become sensitive to what it is I just did that made that work out so well. Like the reason I was able to like carve through that so perfectly was because I X, Y, or Z. Or yes, as I struggled through something, I'm like, oh my God, that was so hard. And immediately after I was like, why was that so hard? And it's like, I have all the information right here because I just happened. Oh, it was hard because I hit this hill at the wrong timing and I changed gears at the wrong time and my feet slipped off the pedals or whatever. And so next time I try this, I'm going to specifically have this one experiment. That might be think about your foot pedal connection, or what's the best gear to be in when you're climbing a hill of this grade? Or, you know, like very specific questions. You don't have to ask all of the questions. You don't have to have the whole lay of the map of like all the nuance of everything, but just try one very specific thing. So that's my approach to everything. And I think having the benefit of having all of these other activities and many of them being sports allows me to interact with that part of myself in a non-exhausting way. Like I'm wiped out at the end of the day. I can't do like lead code problems for fun. I can't like, I have very these days, especially since I'm like thinking so hard these days, hard time like diving into any of the like off hours experiments that I want to run. Like I have all sorts of ideas. Dead. Yeah, I'm just like fried. But my personality is not different. Like I still have all of those desire to ask those kinds of questions and interact with a thing in that manner. And so having the exercises and the various hobbies that allow me to interact with myself and my world in that way, but in a non-exhausting way, in a restorative way, I think has been super crucial, specifically, especially in this pandemic, to like maintaining.
And then you're getting all the trees, right? That's beautiful as well.
Yeah.
Wanted to ask a quick question about coffee. So educate us about coffee. So when I go, okay, if I buy something that's roasted in the store, talk to me about that. Is that
all right? I have.
Let's go to Folgers first.
I'm gonna go hard. So first of all, you should buy your coffee from a coffee shop.
Okay.
Because even if your favorite coffee shop sells coffee at the grocery store and the coffee shop have opposite incentives. The grocery store wants to hold on to things for as long as possible to give it an opportunity to sell.
I see.
And so therefore, you're just not going to be getting fresh coffee at the grocery store because the date they're giving is a sell-by date. Whereas the coffee store is giving you the date this thing was created. So you can know how far am I from when this thing came into existence.
Yes.
Whereas that's not a question you can ask or answer with the grocery store numbers. So your brand for brand, same brand, you'll get better quality at a coffee shop. The next thing is in the roasting process. So the way coffee flavor. So first of all, I hate coffee.
Okay. threw me for a left one there, but okay.
Yeah. So I was never a coffee person. And then one day I had like this mind-blowing espresso. And if you have your own opinions of espresso, I don't know how much like, you know, what your relationship with is, but most people don't like espresso straight up because it tastes bitter and bad to them. And I agree. most espressos do taste terrible. But I had one mind-blowing one that literally tasted like flavored blueberries. And I realized that espresso and coffee in general could be so much more.
Right.
And what I actually hate was not coffee or the flavor of coffee, but the flavor of bad coffee, which is most coffee.
Okay.
And the way coffee works is it's kind of like wine. Yes, it's kind of like wine. When you see all those fancy, like hoity-toity descriptions of a wine next to the bottle, and they're talking, yeah, like they're talking about all these fruits and vegetables and all these things that you're like, none of that was related to the process. It's not like they're flavoring the wine. Where are they even getting like dried fruit from? You know, the processing plus the actual harvest of the item. So in the wine case, it's grapes, has an intrinsic flavor profile to it that gets carried forth in a transmutated form via all the processing. So in the grape case, it's drying and, you know, all the other winey stuff that I don't know. Coffee, it's the same way. If you have coffee from a certain part of the world, which was grown at a certain elevation, which has a certain kind of climate, which was processed in a certain way, and was then roasted in a certain way, then what you're getting is the signature of each of those things I just mentioned when you finally drink it. And often what happens is the last step, the roasting step, and then I guess even one step further, which is the brewing step.
Yep.
Destroys the information from the preceding steps that might have been really great, delicious information. And so that's the way I think about roasting, which is it's an entropy process. How much information should I artistically destroy to reveal and preserve only the thing that I think is the good information to preserve, and without adding too much of my own thumbprint onto this? Or maybe that is my thumbprint. My thumbprint is my artistic decision of how much I've chosen to elide versus preserve.
Dude, you're gonna have me freaking out about the espresso that I'm drinking every day. I'm an espresso fiend and wannabe coffee snob, which I need to get more educated.
Basically, light roasts essentially preserve the majority of the information.
Okay.
That's why you want to go for light roast. It's not because it's intrinsically better or worse for some other reason than you get a much more clear understanding of the flavor of this bean. So like straight up, I'll roast a bunch of different beans and I'll be like, these were all amazing roasts. I did not screw anything up too dramatically, yet I don't like this bean.
So you got to actually see what the true profile of it was.
Exactly. And so that's the thing with coffee is if you go to a coffee shop, like the reason to go to one coffee shop over another, if you're looking for like a really amazing experience, is you can gauge just looking at their light roasts, like how far did they go? Will there be enough flavor profile information in there for me to actually understand whether or not the bean that they are serving me is going to taste good to me? And then from there, you can develop your own preferences and be like, well, I like things that are juicy and sweet. So I like beans that are from this region and that region, or that were processed in this particular way, because those things have been, in my opinion, or my observation, associated with the flavor profiles I enjoy. Very
cool. I have much deeper appreciation for what I'm about to drink after this call. So in the last segment of the podcast, now that we've gotten a deep dive of your career journey, and I think you've shared with us lots of valuable tidbits, but you're very passionate. What would you sort of recommend to listeners? I know you said in some cases you don't have the best answers, but what would you say is the best way to cultivate that passion that, let's say, you have for machine learning? And it seems, if I understand correctly, hey, that's the thing that's happening right now. Until that fades away, it'll become something else. But if you can recapture that, what would you say?
Yeah, I guess before I answer, I want to call out one specific thing, which is that the precursor to being able to be passionate about anything is resources. You have to have the privilege of resources.
Wow.
So whether that's like, I know several women who are trying to break into either software engineering in general or machine learning in particular. And one of them has all the time in the world. and enough money to be able to like make these pivots and invest the sweat. And the other one is literally a mom of a teenage daughter and has a full-time job and all that other stuff. And so it's like she just is like strapped for time. And you know, this doesn't even allow you to figure out what your aptitude is.
Yes.
You're just cut off at the knees. You're like, even if I could be good at this thing, or even if I would be terrible at it and couldn't, you know, decide to quit or whatever, I'll never know because there's this like handicap. So before you can even figure that stuff out, you have to have the ability to invest the time and discover the mechanisms that work for you. So in my case, my, I guess, 3-step process is get a lay of the land, reading foundational material. So there's nothing practical involved whatsoever. Then very quickly move on to project-based, or like try to cobble together some idea, project idea, nothing like prepackaged, a project idea of my own, and then struggle through going through that project, but with the purpose of using that project to generate good questions to figure out what's missing and how do I connect the theory to the practice. And after that, it's a process of refinement of, okay, now I understand how to prepare data. Well, there's like Andrew Ng has that whole data-centric AI movement. Preparing data is now like a whole art in and of itself. And so then there's the art of training models, there's preparing data, there's optimizing models, and all of this stuff. There's all these things you've got to deep dive on, ideally all, but start with one. Pick a thing and try to refine your process for that thing and rinse and repeat.
Yep. And I guess that's based off of, you know, what's coming at you in that moment as well.
Yeah. And I guess one last thing I would add, especially since your podcast is focused on potentially people who are transitioning to from something else. One fortunate detail of my particular circumstance is that I was able to get a role that allowed me to do this full time and be able to contribute right away.
Yes. Okay. Huh.
And so I was able to like continually turn the ship very gradually by continually providing valuable, you know, service to a company that allowed me to pay my bills and whatnot and do all the things. And at no point did I have to pay the full price of like just eject from the industry for a year to like retool.
And that's something I've been thinking a lot about, especially for professionals where you want to transition into machine learning. I'm like, get a backdoor job into a machine learning company and you get to know the data scientists there. You understand the infrastructure. So when a rec opens up, you're like, hey, I know all your tools. I know how your data works. I know all you guys. Let's go. Right. And your passion has so much more benefit to the company. So
yes.
Yeah, happy you brought that up again. Hey, I want your opinion on this thing. Have you read the book So Good They Can't Ignore You?
Yes.
What are your thoughts on it?
I mean, I totally agree.
Okay.
However, it's difficult to fully not feel bittersweet about it because if you're a non-white person in the culture of America, you've always had to be so good they couldn't ignore you. And I think we'll know we've made it when there are a hell of a lot of mediocre Black and brown people in professions. Whereas right now, when I run into people that are non-white, that are doing, you know, all the things that I spend my time doing, I'm like, they're probably very good at it.
Yes.
They're probably amazing. And they generally have been.
Because you just have to be.
You have to be.
That's wow. That was deep there. The last couple of questions I have, what 2 pieces of advice, and I know I may be asking you to repeat certain things, but let's call it out explicitly. What 2 pieces of advice do you have for a high schooler, a person in college, and a professional?
For a high schooler, I would say assess all of the things you like doing. And I don't mean end level things of like, oh, well, I like dancing and I like playing this instrument and I like my science class or whatever. I'm saying assess everything you like from a brain level And for me, if we look back at a survey of everything that I've done with my life, it's always been from day one. I like puzzles and taking things up, systems apart and putting it back together. And like, I like tinkering with stuff. And whatever activity I did, it always became some mechanism of tinkering. Like when I was a musician, I wasn't only an instrumentalist. The thing that I liked about music was composition. And so music theory was like my reason for being in music, is because that was the puzzly aspect of it.
Yes.
So figure out what it is you like about all the things you like. So make the survey of what all the things you like, and then figure out the aspect of it that is shared across all of them. And then map that back to a career or a list of careers, and then sort those careers by which one pays the most. So literally at every point in this process, you're optimizing for things you're A, good at, B, like, you'll enjoy this thing, and C, will give you the life and the freedom to live the life you want. And I think many people are ill-advised by people, well-meaning people in their life, or by professionals, and either skip or get wrong one of these three pieces of advice I just give. And they'll just be like, okay, I'm just going to sort by the internet, like what's the top paying careers right now, and then just pick the highest one. And it's like,
That was me.
It's like, yeah, you could be an astronaut. I don't think actually being an astronaut pays the most, but the point is you could be a rocket scientist, but the distance between you and rocket science at any given moment is probably way further than the distance between you and something else that you might have a better predisposition for enjoying, and also pays, whatever your threshold of good money happens to be.
Cool. So college student, you would
I would say the same
some
thing.
Of that in there.
Yeah, but by the time so I'd say the process is the same always, but at each stage, you should already have pretty clear set in stone answers for certain aspects of this. So like by the time you're in college, you should know the things that you like, and perhaps even decent answers for what it is you like about all of those things, as far as it relates to like the kinds of tasks your brain enjoys doing.
Yes.
And you should also have a better awareness of like careers that are out there. Like, don't ever get into college and be like, I'm just going to underwater basket weave. And I'm sure there's an underwater basket weaving job with that title out there. Maybe make sure, maybe figure out that answer, get that answer. And then if you're like out in the field, like, in my case, I was just a generic software engineer. And then I moved to software engineer at a FinTech, other FinTech, wearables, and all that like embedded type situation, making iPhone apps and Apple Watch apps and Pebble apps and stuff like that. Throughout all of those things, discovering, it's sort of like repeating the process that I just listed, but specifically only in the domain you're in. So, okay, I know I'm in software now, but there's so many kinds of software. I could be an operating system developer. I could be a compiler engineer. I could, write firmware for, routers. There's so many things you can do. You have to now go back through and maybe do a weekend project in all of those things, or like read a few textbooks in those things, like try to get a visceral understanding of where you would like to be if you're not already accidentally there. And then watch this podcast to figure out how to get to that point.
I like that one. So the other question I have, we are trying our best to encourage people from the Caribbean diaspora to leverage some of that background in their professional careers. So can you maybe comment on how your Caribbean heritage may have contributed to some of the successes that you have had? Any thoughts there at all?
Oh yeah, this is another possibly weird thing to answer. So I think being from the Caribbean puts you in like an ethnically ambiguous place, which in the United States can be advantageous. Whether or not, like, I'm not saying you're like actively going out there and pretending to be one thing or another, but I'm saying like you might fall into a bucket of people's predispositions and prejudices that happens to be advantageous. And so that's one aspect of it. That's more of a, you can't really control who you are kind of aspect of it. But then another aspect of it is, I think Caribbean culture, a lot of it is very education, like I remember David Rudder, when I was growing up, had a song about, little black boy, go to school, learn, get your education. Like that, I think it's pretty well understood throughout the Caribbean that education is super important.
Yeah.
And I totally agree with that. The more you have to be a builder, build something. And furthermore, I think that being from the Caribbean gives you a multicultural perspective that is becoming increasingly important. Like, I think the African American experience and the Caribbean American experience in their origin share a ton of similarities, also have a lot of differences. But I think the union of the two, if you can understand both of them, you can contextualize yourself and your life in such a way that it can make you better at whatever it is you're doing. Mm-hmm. So in the case of machine learning, I'm extremely sensitive about taking the pains to make the AI that I bring to the world fair, just, equitable, and like I have a better sensibility of the mechanisms or the manners in which it might be unjust, unfair, or inequitable.
And the corresponding repercussions of that, right? Like
exactly.
He might be the one on the receiving end of it.
Exactly. Exactly.
Great. And you shared a lot of life principles, but if you could define them quickly, what are 3 principles you live by?
I find it very painful to be bad at things. So one principle I live by is to quickly determine the things I care about and throw myself into it. So fall in love with things.
Okay.
I shouldn't say fall in love with things. Fall in love.
Okay, I like that.
So that, and that could be like with people, like you can, like the way I look at the world, you can then look at people that way and see people as this like fractal of, or I guess mosaic is a lot more friendly, mosaic of pieces that makes them up. And you can interact with and enhance and bring out some of those pieces that either may be suppressed or maybe connect with more. And then
some of those pieces from them also will push you up as well, right?
So I think fall in love is one of my principles. And then of course, this whole podcast was about falling in love with various things about software and machine learning. And then another principle is none of this means anything. Okay. I mean, it really doesn't. We're just here, right? We don't have the full picture of exactly how we got here. I mean, I spent a lot of time on YouTube trying to figure out like the age of the universe and how we got here, but that doesn't answer the questions that I have. And we're just here. There's no actual meaning to it. So try not to let yourself get caught up. And I'm very susceptible to this, to getting caught up into the maelstrom of whatever it is you're getting caught up in. So for me, especially with my startup background and my, all the various things about who I am and my personality, it means I'm prone to overworking and stressing myself out and like all sorts of other bad knock-on effects of that.
Yes.
None of this means anything. So just do what you got to do and then like try to experience something good.
Ooh, I like that. Okay.
And then I don't know if I could come up with a third one.
It's okay if you can't, because those first two are pretty strong.
Yeah, those 2 are the ones that like I'm continually reminding myself of, because obviously it's a practice. It doesn't come naturally, and there's nothing in our world that reinforces any good habits about anything.
I would almost put that one as your third one. It's a practice, right? It seems great. And so my last question, what are 3 books you recommend for people to read? You could split that into machine learning or just life in general, even though it's meaningless to some degree.
Well, it's meaningless in the grand scheme, but it's meaningful in the local.
Absolutely.
If you can pick one book from any of these authors, you'll have done yourself a service. If you can pick a James Baldwin book or a Toni Morrison book, you'll have been better for it. Specifically, Ta-Nehisi Coates's book, Between the World and Me,
Okay.
I think was, especially as a Black man, first of all, it's just an objectively beautifully written book. But then as a Black man, it was extra resonant. And with machine learning, I think
Yeah,
way
I want to hear your book for machine learning.
well, so the criteria for the machine learning book is this thing changed the way I looked at the world.
Okay.
And I think it was a confluence of when it arrived for me, and it was Christopher Manning's information retrieval book.
Oh, really?
That was the first machine learning book I read. I started with that book instead of The Bishop or the Hasty, and he's a great writer. And I think that allowed me to see the world in a whole new way. And then likewise, I bet this could be served by any book, but, and I actually haven't even read this one yet. I know that people have said this is the way this book is, and that's why I would like to read it. So Leonard Susskind, he is a physics professor, and his treatments of various topics in textbook form are apparently extremely enjoyable to read, just like for the edification. And finally, any book about mathematical proofs.
Okay. Yeah, that's a strong one.
Yeah. Like I have the one that I like, which...
Is it real analysis or something? Or Rudin? Is it Rudin? That book is heavy.
Jay Cummings.
Jay Cummings. Okay.
Yeah. It's... one moment. Wait. I can find this. I'm on the internet.
Yeah, and I think thinking about proofs or the mechanics of proofs, at least if you want to go down a super technical route, is a great way. And someone I just interviewed, Dr. Kokoram, who's a big professor at Trinity College Dublin. He made this very intuitive, but I would call it miraculous statement, such that when you go to solve a new problem or like a proof, it's almost like you're looking into the future and maybe pulling some bits forward to just get you to the next step, so that you can, and you're continuously at each, you get to this level. Okay, let me look forward just a little bit. I don't know what the full picture is, and sitting in that ambiguity of not, there's no solution for this problem. So you're discovering it as you sort of move along,
Oh, I totally agree. The title of this particular proofs book is that is by Jay Cummings, is a long form mathematics textbook. And it has surprisingly few formulae in it. It's like a lot of narrative.
Okay.
And it's really like, I think studying any proofs book probably will have this, you'll have this experience, but this one I think was very transformative for me, because it mirrors a lot of the kind of lens that you need to have specifically in software, but I think would be beneficial for everything in life. And just unraveling, like, if we were to like put it in an entirely different domain, unraveling the mechanism that created or that underlies the systems that we are experiencing. So like, you look at the proof that can be applied in multiple situations, like the pigeonhole principle or whatever. It applies in all of these different places. They look like different situations. They're all the same principle. And this principle is a fundamental truth and a fundamental relation based on this explanation, which is the proof. And if you look at anything in our world, especially in this world of misinformation and propaganda, that kind of lens, I think, is extremely powerful. Okay.
Now you make me very curious about this book. So thanks very much for the time, and I appreciate all the lessons that you shared. I'll definitely be reviewing this. quite often and taking some of your lessons, especially from the coffee side. And once again, thanks very much for your time.
Thanks for having me. I enjoyed it. It was a really great interview and a lot of great questions. Thank you so much.
Great. All right. We'll catch up with you soon.
Okay, bye.
Later. I hope you enjoyed today's interview and took away some great perspectives for your own journey in machine learning and tech. The field of tech, machine learning, and AI will have a great impact on the Caribbean region, so make sure you are involved. Remember that your Caribbean heritage is a great asset for your professional career, so take advantage of it and keep working on your skills. Later.